Hello viewers, welcome back to BakoMaths, and today's lesson we'll be looking at how to prove the formula for the inverse of a 2 by 2 matrix. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we have this, and it says that given the 2 by 2 matrix A, which is equal to ABCD, we want to prove that A inverse is equal to 1 out of AD minus BC multiplied by the matrix D minus C minus BA. So basically, we want to find that A inverse is equal to 1 out of the determinant times the adjoint. And so we continue. So at this point, we have been given A to be equal to A, B, C, D. And we want to find A inverse. But since we don't know A inverse, we can say A inverse should be equal to X, Y, Z, W. But we know from the fundamental matrix identity, it says that a matrix times its inverse should give us the identity matrix. So at this point, we can say that identity matrix should be equal to 1, 0, 0, 1, since we are dealing with a square matrix of 2 by 2. And so when we substitute, then we have the matrix A as A, B, C, D multiplied by A inverse, that is X, Y, Z, W. Now it's equal to the identity matrix 1, 0, 0, 1. Now at this point, we are just going to multiply the two matrices, that is A and A inverse, and equate to the identity matrix. And so when we look at A, B, it means that AB is going to multiply the column XZ. And so when they multiply, we are going to have AX plus BZ is equal to 1. And with this, we can see, let this be equation 1. And we can see that CD also going to multiply XZ, and we are going to have CX plus DZ to be equal to 0. So we can label this as equation 2. Now we continue, and we can see that AB is going to multiply YW, and we have AY plus BW to be equal to 0. And we can call this as equation 3. And then we can see CD multiplies YW, and we have CY plus DW, and this happens to be equation 4. Now we can see that equation 1 and 2 looks similar, and in that case we can use either by elimination or substitution procedure to find X and Z. And so we can say that from equation 1, and 2, we know AS plus BZ is equal to 1 and CS plus DZ is equal to 0. So by the procedure of elimination, then we can multiply equation 1 by C and also multiply equation 2 by A. So when we multiply, then we are going to have a new equation as ACX plus BC BCZ is equal to C. And when A multiplies equation 2, we are going to have ACX plus ADZ is equal to 0. So at this point, we can call this as equation 5. We can also call this as equation 6. Now, the idea here is that when we subtract equation 5 from 6, then we are going to get the value of X. Z rather. So we want to subtract equation 5 from 6. And when that happens, then we are going to have ACX plus ADZ is equal to 0, and have minus ACX plus BCZ is equal to C. And so ACX minus ACS gives us 0, and at this point we have ADZ minus BCZ is equal to minus C. So we can see that Z is common in both ADZ and minus BCZ. So you can factorize Z out, and we have AD minus BC multiplied by Z, and then we have minus C here. So in making Z the subject, then we can divide here by AD minus BC, and we have here AD minus BC. So this cancels that, and we have Z to be equal to minus C divided by AD minus BC, and this becomes the value of Z. Now, in finding the value of X, we can substitute Z into either equation 1 or 2. So we intend to substitute into equation 1. So by substituting, you can write it as by substituting Z equals minus C out of AD minus BC into equation 1, and we know equation 1 to be AX plus BZ is equal to 1. So we have AX plus B. Now Z is minus C out of AD minus BC is equal to 1. So when we expand, then we are going to have AX plus, so it should be AX minus BC out of AD minus BC is equal to 1. So we can bring BC to this side, so we have plus BC divided by AD minus BC. So at this point, we can find the LCM for the term we have on the right hand side, and so we have AX is equal to the LCM for this term and that term is AD minus BC. So AD minus BC goes into 1, we have AD minus BC itself, and AD minus BC goes into AD minus BC, we have 1 multiplies BC, we have plus BC, and so we can say that AX is equal to AD, so we have AS to be equal to AD minus BC plus BC out of AD minus BC. So at this point, we can see that this will take this one off, and we have AX now to be equal to AD divided by AD minus BC. So in finding X, we can divide here by A and also divide here by A, and A will cancel A. We have S to be equal to AD minus BC, then multiplied by the reciprocal of this is 1 out of A, and this A takes this A off, and at the end we are getting X now to be equal to D out of AD minus BC. So now we have the value of X now. So the remaining variables now is Y and W, and we can find that from equation 3 and 4. And so we can say that from equation 3 and 4, we can see AY plus BW is equal to 0 and CY plus DW is equal to 1. So basically, to eliminate one of the variables, we can multiply here by C and here by A. And so when that happens, we are going to get ACY plus BCW is equal to 0, and we have ACY plus DW, so ADW is equal to A. Now to eliminate one, so before that, remember, we can call this as equation 7 and call this one as equation 8. So we intend to subtract equation 7 from 8, and we can simply write here as subtracting. Let's take it back. Subtracting equation 7 from 8, then we are going to have ACY plus ADW is equal to A. We have minus ACY plus BCW is equal to 0. And we know that ACY minus ACY gives us 0, and we have ADW minus BCW is equal to A minus 0 is A. And we can see that W is common in the two terms, so we can factorize W out, and at this point we have AD minus BC. So W comes out and we have is equal to A. Finally, for W, we just divide here by AD minus BC, and we have here as AD minus BC. So this cancels that, and we have W to be equal to A out of AD minus BC, and this becomes the value of W. So we can substitute W into equation 7 and 8. So any of them goes. So we intend to substitute into equation 7, and with that we know that from equation 7 we know that AY plus BW is equal to 0. And so when we put the value of W into this one, then we are going to get AY plus B. W now is A out of AD minus BC is equal to 0. And so when we multiply, we have AY plus AB out of AD minus BC is equal to 0. So at this point, we can send AB divided by AD minus BC to the left hand side, and that becomes AY is equal to minus AB divided by AD minus BC. So with this, so from equation 7, but we know from equation 7 that AY plus BW is equal to 0. So we have AY plus BW to be equal to 0. And when we substitute the value of W into this equation, then we have AY plus B, that is A out of AD minus BC to be equal to 0. So when we multiply, then we have AY plus AB divided by AD minus BC to be equal to 0. Now we bring AB divided by AD minus BC to the right hand side, and we have AY to be equal to minus AB divided by AD minus BC. So in finding for Y, then we can divide here by A and also divide here by A, and we know that A will cancel this A, and we have our Y now to be equal to minus AB divided by AD minus BC. So at this point, we can reciprocate this, and we have 1 out of A. So you can see A will cancel this A, and we have Y now to be equal to minus B divided by AD minus BC. So basically, we've been able to find the values of X, Y, Z, and W. And so to summarize our solution, then we have X to be equal to D divided by AD minus BC, and Y to be equal to minus B divided by AD minus BC, Z to be equal to minus C divided by AD minus BC, and W to be equal to A divided by AD minus BC. So remember that we said that we should let A inverse be equal to the matrix X, Y, Z, W. And so when we substitute these values into A inverse, then we are going to have a bigger matrix, to be precise, as, so we know our X to be equal to D out of AD minus BC, and Y now is giving us minus B out of AD minus BC, and we know Z to be equal to minus C out of AD minus BC, and W now is A out of AD minus BC. So now at this point, we can see that AD minus BC is common in the four values. So values of X, Y, Z, and W. So we can factorize that out, and doing so, A inverse is now equal to 1 out of AD minus BC, and after factorizing, you can see D is left. At this point, you have minus B, this side have minus C, and here we have A. And this becomes the proof of the inverse of a 2 by 2 matrix. So the inverse of a 2 by 2 matrix is giving us 1 out of AD minus BC, and then they are joined, that is D minus B minus C A. And this ends today's video. And so thanks for watching. Kindly like, comment, subscribe, and share. Remember that this is BakoMaths. You are thinking beyond infinity.